Great. Wonderful. Okay. So as I say, what we've done so far has been talked a little bit about the very first kind of moves in the grammar here of TFL. And what I want to do for the rest of the time, so the next 35, 40 minutes, is first have a little segue about this philosophical distinction between use and mention. And this is really just us getting clear on some things, making sure all of our ducks are in their various rows. And that will set us up for the last bit, the really kind of directly important bit, where we define the notion of a TFL sentence. So we'll go through this bit kind of quickly in order to get to the exciting things. So the first thing we can talk about with use and mention, we can start by looking at these sentences and asking ourselves which of these are true and which are false. So our first one, right? Nathan's a philosopher. That's true. Nathan is a philosopher. Right? Something's kind of gone wrong here. Similarly, Nathan is composed of 6 letters. Nathan is composed of 6 letters. That seems much more digestible. What's the difference? The difference is small, it's typographical, but it's very important. It's the quotation marks, right? The inverted commas. And the quotation marks are playing a very important role here, because what they're doing is they're indicating in the 2 sentences what the sentences are actually about. The first sentence is about me. What's the second sentence about? Yeah, it's about my name, right? It's about my name. It's not about me, it's about the term we use to pick me out. It's about a word. That's also why the second pair have the kind of readings that they do. And it's a simple, very small thing, but it's a very important thing to see the difference. Right? So, when we want to talk about Nathan, for whatever it is, right, we use his name. But when we want to talk about the name itself, we mention the name. So we can think about it this way, right? When we want to talk about the world, we use words. When we want to talk about words, we mention them. You can think about basically words as a little bit like a doorway. If you want to get out into the world, you got to use it. But you might want to stop and just admire the door itself. That's when you mention it. And how do we indicate when we're mentioning and not using? Because use is going to be the standard operation here. Well, we've already covered it. Inverted commas. The inverted commas, the quotation marks, tell us when we're mentioning a word, when we're talking about the word itself, rather than whatever the word stands for. Notably, in this context, when we're thinking about formal logic, they do not indicate indirect speech, like in this quote. My favorite quote ever. What do the inverted commas do, at least in the context of formal logic? They indicate that we are mentioning the relevant word. We are talking about the string of symbols itself, not whatever it stands for. If you want to play around, here's a very fun little sort of poem. Think about lots of different ways you could plug in quotation marks to make this true. Not even just grammatical, but actually true. Again, something fun to play around with. But the important thing is, right, when you mention a word, you don't go through it to whatever it refers to or it designates. You just simply stop and talk about the word itself. Nothing should be really shocking here. And if you've done some programming before, you've run into something along these lines, right? There are some times when you want to talk about just the string of symbols, or you might want to talk about what the string of symbols is representing, referring to in some way. We can extend this, and in fact, think about languages. When we talk about a language, the language we are talking about, we'll call the object language. It is the object of conversation. It is the target that we're talking about. Then the language that we're using to talk about that is our meta language. If you think about today's lecture, the object language has largely been TFL, truth functional logic. The meta language that we've been using, that I've been using to teach you, is English. A kind of augmented English, because it's augmented in the sense that things like the negation and the conjunction and the disjunction aren't really a part of everyday English, but, it's still basically the same thing. Now, we mentioned this just to highlight there's a difference here between the language that we're using to talk about TFL and what TFL itself can say. Notably, everything we've said so far in this lecture is inexpressible in some sense in TFL, because we're talking about that language, and it doesn't have the tools to let you do that. That's fine. So, a thing to really drive home. This is technically true. D is a sentence, an atomic sentence of TFL. This is not. Because this is talking about the letter, not using it. Nothing really deep and important here. But again, this is just being very clear. We've got to be a little bit careful when we're thinking about talking about our language versus what our language can actually say, what it's for, what it's doing. Now we run into a problem, and this is one of the reasons that I want to mention these things. Quotation marks are fine, but quotation marks are also kind of restrictive. Think about Nathan. Nathan works fine, but it only lets you talk about that one name. What if I wanted to talk about any name? Or any word of English? Or any noun? Quotation marks only let us pick out or mention specific expressions, but we might want a tool to allow us to talk about all potential expressions. In fact, we've already seen this. Think about the grammar rules that I was giving you earlier. Remember, we say something like, hey, something can be symbolized as brackets, A conjunction B, close brackets, if blah, 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 blah. Those where I was using A and B, that wasn't standing for any particular TFL sentence. It needed to be any TFL sentence, simple or complex. So how do we do it? You probably already clocked it, or if you've got the slides from earlier in front of you, you will have already seen. We do it with this sexy swash font. We indicate the difference here textually with a font. This is a specific TFL sentence. This stands for any TFL sentence at all. This is not part of TFL. This is part of English that lets us talk about any part of TFL. It's not a super important thing for what we're going to continue on to do, but it's conceptually important that we see the difference. This is a tool in our meta language that lets us say things about every possible sentence or expression in TFL. Tool in English. Yes. Do not stress. I'm never going to ask you to write this. If you put regular letters versus writing the sexy swash font, I'm not going to fuss. This is something, again, for us to get our conceptual ducks in a row, rather than something that will be on the exam, and I'm asking you to show me your cursive. Don't worry about it for exam stuff. This is something for us to be very clear conceptually. Again, to be real honest, this is something to make sure that the rules I'm going to give you are grammatical. That they aren't just like, hey, you can only ever go from literally the sentence A to literally the sentence B. That's the only reason really here. Okay. So, my sexy swash font A is a symbol in augmented English used to talk about any TFL sentence. This is why it's featured in our grammatical rules. It's basically a meta variable that allows for any sentence, for those of you interested in that term. Again, this was a segue. It's just to be a little bit clear. I'm going to use this sexy swash font going forward. I've already used it, but it's going to stand in quite a bit for what we're about to do next. That's why it's important that we do it. So now, let's talk about defining up sentences in TFL. If we think about TFL, it's actually an incredibly simple language. It basically has three kinds of symbols that make it up. The first one, the most obvious one, are atomic sentences. Capital letters, maybe with subscript numbers if needed. The second parts are the connectives. And we talked the past hour basically about the grammar for these connectives, how they work, when to use them. The last kind of symbol, it's implicit, and in fact we've used it a bunch. It's the brackets. And the brackets are really here just to tell us how the units chunk up. They're to help us be clear on grammar. This part goes with this connective. This part goes with this connective. These two link up with this bigger connective. So let's say that an expression of TFL is any string of these symbols. Any string. So if we wrote, A, B, C, D, E, F, G, H, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z, all capital letters, cool, that is an expression of TFL. If we just put bracket, 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 cool, expression of TFL. If we didn't have the commas here, and just this list, that would be an expression of TFL. But much like how any random string of English letters isn't necessarily going to give you a word, or any given string of words isn't necessarily going to give you a sentence, not all TFL expressions are sentences. They don't actually say anything. So when do they? Which expressions are going to count as sentences? It's real easy. First is if you have individual atomic sentences. A capital letter, 1, by itself. Cool, that is the simplest possible TFL sentence. It's literally just whatever atom it is. That's the easy one. Okay. The second kind of expression that's going to be a sentence is a further sentence formed out of atoms using the connectives in very specific ways. And the third kind is there is no third kind. Fuck you, there's only two. The trick is going to be spelling out the second step. And I'm going to give you a definition that spells out the second step explicitly. But note that this tells us something. You can never have a TFL sentence that doesn't include at least one atom as a part. You cannot have a TFL sentence that doesn't include at least one atom as a part. It is the basic building block. Everything else is going to be built from it. It might just be the little Lego on its own, or it might be the little Lego strung up together with a bunch of different Legos connected via, shockingly, the connectives. So, what's the definition for our second one? Here is the definition for a TFL sentence. Let me stress, note that this is in red. I'm not going to ask you for this as a definition on the midterm or the final exam. But this is the beautiful grammatical rules for this language laid explicit and bare. So, what counts as a sentence in TFL? Clause 1. Every atomic sentence is a sentence. Every capital letter on its own, cool, sentence. That's basically just number 1 that I told you a second ago. Now, clauses 2 through 6 are how we flesh out point 2 from the previous slide. And it says this, right? Here's clause 2. If sexy swash font A is a sentence, then you can stick a negation in front of it and get a sentence. If you've already got a sentence, bolt a negation in front. You're still playing the grammar right. Second one, if A and B in sexy swash font are sentences, then you can take them, put a conjunction in the middle, and put brackets around it and get a sentence. The third one is the same, we just replace the conjunction with a disjunction. The fourth one is the same, we just replace with the arrow. And the sixth one, we just replace with the bicondition. So the thing to note with 2, 3, 4, 5, and 6 is you have to already have parts. Have to have parts. It says if you've already got a sentence, then you can make it by bolting on front or building with these in the middle and brackets on the outside. But the best clause, my favorite clause, clause 7. Nothing else is a sentence. My rules. Right? If you don't follow the 6 grammar rules, 1 through 6, you're just an expression at best. Now, the really cool thing about this definition of a TFL sentence is it's recursive. It begins with specific base elements, in this case, the atoms, and details ways to generate infinitely many more using very specific steps. And that's cool. I mean, that's neat. It's nice that it gives us a way to generate infinitely many, but it also tells us a way that we can always show whether something is or is not a TFL sentence. We can decompose it. Take something that is an expression of TFL. We can test whether it's a sentence by seeing if we can reverse engineer which rules were applied to build it. Think about this conceptually as we come across some expression and we hunt along and find which connective was added last. Which one of these clauses was used last? Find the connective that was added last. Break it at that point. Take the parts that you have. Do the same process. Find the connective that was added last for that point. Break it there. Keep on snapping until you come down to the atoms. If you can't do that process, then you know that you didn't have a sentence to begin with. Because there's some point in which it hits clause 7. Didn't follow exactly these rules, not a sentence anymore. It's easiest to see this. I'm going to give you first a slightly jokey example, and then we'll go through a slightly more complex one. Here's the jokey one. Not, Q. 6 of them. Sentence? Well, here's how we tell. We take the expression, and we find which connective was added last. In this case, it's very easy, because there's only the negation. So it was the negation that was added on the outside. So we snap that off, and then we have 5. Well, we got to tell if that thing's a sentence. So we snap that off, and we have 4. And you can see how this process goes until we get down to just atoms. And when we hit atoms, how do we know that they are sentences? What is it that guarantees the atoms are sentences? Yeah, clause 1, right? Clause 1. Clause 1 says every atomic sentence is a sentence. So if you do the process, you follow the rules backwards, and you end up with just capital letters, know that you started with a sentence. So this obviously is a little bit jokey. This is an easy one. You literally just keep snapping the negations until you get down to Q. Let's go with a slightly more complex sentence. Sorry, gave the game away. Here's a rather hideous looking beast. Now, first thing, is it an expression of TFL? Is it an expression? It's just some string, some, to use the fancy word, concatenation. It's just a fancy word for list. It's some concatenation of the symbols that make up TFL, in any order, we don't care. So the trick now is it a sentence? Let's think about the process to show that it is. We look at it and we think about how was it built, but we're going to go in reverse. So we look at this thing and we think, okay, cool. Well, given where the brackets are, we know that the last thing added, the last connection added, is the negation. So we snap it off and we say, okay, the big thing with the negation is going to be a sentence if the thing without the negation is a sentence. And remember, the reason why, clause 2. So okay, now we got to tell, hey, is this thing a sentence? Well, our move is going to be basically following the order of construction downwards. So we look to see what connective was the last one added for this. Here's where we start to get better, right? We start to see we can help ourselves by thinking about the brackets. This is why the brackets are so helpful. The brackets tell us where are the chunks, where are the units. So in this case, we can look at the brackets and see, oh, hey, there's a unit over here, but this one's only got the one. So, bang, there is our most recently added connective. That's the breaking point. So we snap it there, and we look at the two disjuncts. One of them's real easy. Is that a sentence? We know it has to be because of clause 1. So we're already Bon Jovi'd. We're halfway there. But now we got this beast. So we continue with the same process. We look to see, right, what was the connective added here? Where's the next high point? And it's the and. So we snap it there, and then we keep looking at the parts, and we keep stripping each part down and down and down and down and down until we end up with just atoms in every case. And if we can do that, if we can strip it down and end up with just atoms, then we know that actually the thing we had at the beginning is in fact a proper sentence. Now I'm really berating this and driving it home to kind of give you a grip on the fundamentals of the grammar here. To give you an insight into TFL, and this is something we're going to talk about next week. TFL is called truth functional logic because really what we're building is conduits for truth. What we're going to do is basically flip atoms on and off. Make them true, make them false. And then we're going to see, does the truth flow all the way up to give us the big sentence at the top? That's why it's helpful to do this deconstruction process. It's making sure that all the pathways are lined up just right. Because if we don't set them up right, the truth ain't going to flow right. That's why we start with grammar first. So what we're going to do, yes, please. Good. So we can answer that by looking at our rules. The rules define exactly how the grammar works. Note here, there is no need, unless you already have them, to put in brackets. If you add a negation to a sentence to get a new complex sentence, you don't need to add brackets. The only time we add brackets, according to our definition of when a sentence is if you introduce conjunction, disjunction, conditional, or the biconditional. Should not be adding brackets at any other time. Because what happens if you add them at any other time? Then you break rule 7. Now, let me stress, these are the strict rules. We're going to start off by learning the strict rules because, again, it's helpful to learn the shallow and pedantic stuff first. But we're almost immediately going to relax these rules. It's going to be perfectly fine if you don't write the brackets on the outside if they're not strictly necessary. But it's good to get in good habits. So follow the definition here, at least as far as you can. Okay. Yes? Absolutely, right? So let's take this one right here and imagine that instead of this symbol, right, we just had a negation. If we did that, right, we go through this whole process all the way down to right there and realize, oh shit, there's no way to build this complex. This is why the deconstruction step is so helpful, because it's basically seeing, okay, I see the rule that built me this complex, so let's think about how did I build the parts. Oh, I see how I built this part. Oh, I don't see how I built this part. So this whole thing can't be right. That's basically what this is trying to unpack. Now again, this is conceptual, right? I'm not going to ask you a question like this on the exam, but we have to know this in order to be able to do the stuff I want to ask you. Got to make sure that we're building grammatically correct sentences in order to assess them. Got to at least say something to figure out if you're saying something true. Trust me, this is a lesson I've learned a lot trying to learn Dutch. So, a couple things to kind of wrap up here. Every sentence of TFL is going to be constructed out of atoms in the sense that either it will be atomic or it will have atoms as parts. And when it comes to our complex sentences, the ones that aren't just atoms on their own, there's always going to be a connective that was introduced last. We'll call this the main logical operator. Now, there'll be some times when you're tasked with finding the main logical operator, either because that'll be explicitly what the question's asking you to do, this is something in some of the homework, or because it's something we need to do for assessing the truth value of the sentence. How do we do that? Well, there's two pragmatic steps. Note that these steps only work if the sentence is written according to the strict rules defined here. But the first way to figure out the main logical operator is look at the sentence. If it's got a negation in the front, then the negation is the main operator. It was the one added last. It was slapped on to the rest. Done. Otherwise, start counting the brackets. Every time you hit a left-hand bracket, put a finger up. Every time you hit a right-hand bracket, take a finger away. When you hit an operator and you have only one finger up, that's going to be the main operator. I know that sounds weird, but I'll show you. Take this one. And ignore the outside one here. Ignore our outside negation, right? So pretend that was deleted. So we can look at this one here. What's the main operator of this sentence? Well, let's do it, right? We hit the left-hand bracket, we put a finger up. We go along. It's not the atom, it's the disjunction. That was the one that was added last. Now, how about in here? Let's look at this part. Here we hit our one exception. Put a finger up. Oh, we hit the negation. Is the negation the main operator here? No. What's the main operator of this sub-sentence? It's the conjunction. It's the conjunction. So this tells us the one exception when we're doing our counting. And does everybody, but before we move on, do we see why the conjunction is the main operator of this sub-sentence? It was the last connective added to this sub-sentence, the last step in building this, which was then used for subsequent steps. So this highlights, if you're doing the counting method, don't pay attention to negations inside brackets. Those ones, they go away. But it's the other boys, that's the one that matter. We'll talk more about this. You'll get a lot more feel for this as you go along practicing symbolizing. But this is a way to start to see what was the last breaking point, what was the last connective added. Here's really cool. We mentioned earlier this notion of scope. Remember we talked about when the negation was on the outside of the conjunction or when it just negated one of the conjuncts? Well, we can use what we've defined to give a proper definition of scope. You can say the scope of a connective in a sentence is the sub-sentence for which it is the main logical operator. That is, it's the part of the big sentence we're dealing with where it's the big man in the part. It's the last one added to build that part. The final point I want to make before we move on is the reason why we have to have brackets, at least sometimes. We have to have brackets because without them, we cannot understand the grammar. Take this. Expression. This little thing here in my bullet point. Expression of TFL. Yeah, it's an expression, right? It's any kind of string of the symbols that make TFL up. Is it a sentence? Well, I mean, if it's a sentence, we should be able to use that sort of deconstruction method to figure it out. Problem, where do we start? How do you chunk this? Who's doing what to who? We can't tell. Put another way, take our conditional here, right? Our conditional, well, cool. Is the thing on the left, is the antecedent just R? Is it not R? Is the consequent P? Or is it this disjunction? We don't know what the parts are. This is why we have to have brackets to tell us what the parts are, what the chunks are. Now, it's worth saying, again, the strict definition that we had earlier of a sentence, this gives us the strict rules for using brackets. You will never be marked off for using the strict rules. The midterm, final exam, anything like that. I'll also say, and I'll say this now to the recording, I am happy, here's a loose rule. I'm happy if you drop the outside brackets. It's perfectly fine. So you know those ones, the examples I had earlier, where we didn't have brackets around the outside, but it was very clear where the chunks were? That's fine. You guys can do that. You'll never lose points for that. The only time you are going to lose points for bracket issues is when you give me something like this. If there is grammatical unclarity, then you haven't said anything. You might as well have just gone like, cool, not the right answer. Sorry, did you have a question a second ago? So, it's a good question. So when we look at these, in some sense, every time we do the deconstruction step, we're always figuring out the scope of the relevant connectives. So for example, let's take this sub-sentence. The scope of this conjunction is the whole subsentence. The scope of this conditional, what do we think? What's the scope of this conditional? So it's going to be from this bracket to that bracket, right? It's the sentence that it's the main operator of, the thing that it was used to build, right? So it's going to be basically this right here. That's what our conditional scope is. So this is something we're going to practice as part of the homework. But again, something we're going to get better at as we keep going. Okay. So, to wrap up, right, what have we done? We learned the basic, right? Please don't block that because that's the projector here. Thanks. So what have we learned, right? You you have now learned the entire grammar for TFL. Look at you. It's amazing. In one lecture, you've already mastered a foreign language. But what we haven't done yet is figured out when TFL sentences are true or false. That's what we're going to do next time. So, ask you then to please read this bit of the textbook. It's going to talk to you about the tool we're going to use to develop, or the tool we're going to develop to say when sentences are true and false. And what we're going to work on in the tutorials this week is going to be practicing building these sentences, capturing the symbolizations correctly, and making sure the grammar fits. Yeah. Nah, so this is for the next lecture. This stuff's always for the next lecture. Cool. Thank you guys for coming. Have a lovely rest of the evening, and we'll hopefully see you later this week.